Okay, so what you have to do, Harry, am I recording? Oh, yes. What it means to, do you see my MATLAB screen?
Not at the moment, but that might
What
be
do you,
my
okay,
fault.
so I'm not sharing, yeah, okay, so I'm not sharing. Here it is. Okay, so what should happen is that you have a subdirectory that's called lib, and you have it directly under your C. And then you go inside, there is this E246 tool. This name comes from the fact that EE426 used to be the image processing class I taught at Cal State. And then you go inside VC tools, yes, and here there is, you should have a file that's called startup RVC. And you click on it and automatically open MATLAB.
So this is, you open that file
Yes.
browser from within MATLAB.
No. This is just
It's a
Windows
normal
Explorer,
file
okay?
window, and so when you click it, oh yeah, because I see it's called, Windows knows it's MATLAB code.
Yeah, and so opens MATLAB, okay?
Okay.
And then you have this is, what is it? Startup _ rvc.m, and then you just run it.
Ah, okay.
Like this. Change folder.
Why did you change the folder?
Okay, when MATLAB was in a certain directory, when you run a program, it moves to the directory where you have the program.
Oh, okay.
It does it automatically. Okay. Now, do you all know MATLAB, or somebody doesn't?
Oh, I don't know.
You don't know MATLAB, okay.
I don't know it, sorry.
Okay, no. That's good. So we start from the very, very beginning. So you have opened MATLAB like the same way I did. And let's create a new file. So new script. Okay, so this is an empty script. And actually, let me do this. Later. View. I would like. When you run MATLAB, I'm back here. When you run MATLAB, you have an editor, and then you have a command window that here I see under, which this is my editor, and this is my command window where I see the results of whatever you are doing. And there is a way to put everything in the same page as the default. Oh yes, if I do a default view, this is my editor, and here down, this is my command window when I see the results of whatever I'm doing. So what you can do, you can just use MATLAB like a calculator, something that does your calculates things for you. For instance, if you do 3 × 5, return, calculates 15, okay? Or for instance, you can create a vector that contains the number 1, 2, 3, 4, 5, and you can do like this. From 1, with steps of 1 until 5, you write this, and you get 1, 2, 3, 4, 5. The grammar is the following: initial number, semicolon, the step that you want to use, and the final number. This is the grammar to create vectors that have a certain regularity, okay? So for instance, if I do 0 with steps of 2 until 10, I get the vector 0, 2, 4, 6, 8, 10. These are useful commands. So you can just give the commands on the command window. But then once you've given the commands, they are lost. You can go back to your commands with the up up arrow. Okay, so you see I'm typing the up arrow and I go back to my various commands, but it's not very convenient. So generally what you do, you write your commands inside a script and then you run the script so the commands remain there and are not lost. Or if you have any question, or if I say something that you already know and is not useful, please interrupt, feel free to interrupt me any moment. Another thing you want to know of MATLAB is that the comment is percent. So for instance, I'm writing my script. This is a test script. And when you start your script, generally you want to close all possible windows, MATLAB windows you may have. So you generally start with close all. And sometimes you also use clear all to clear all the possible variables that you may have. You see, when you write something and MATLAB marks it in red, like here, all is marked in red, means that, yes, some comment is not very happy about it. So you can put your mouse on top of the whatever is marked in red, and you will read what MATLAB has to tell you. For instance, he says, using clear all usually decreases code performance and is often unnecessary. Okay, so let's take it away. MATLAB doesn't like it. And so let's start writing our commands. For instance, yes, we want to make, let's see, I'm going to, for instance, generate a sinusoid that contains 100 points, and I'm going to plot it. This is what I'm going to do. So to generate a sinusoid that contains 100 points, I need to initialize n to 100. This is the number of points I want. In MATLAB, general, when you want a command to be silent, you put a semicolon. Let me show you what this means. I wrote n equal to 100. Let me save the program I'm writing at the moment. As you can see here, MATLAB marks it as untitled. But because at the beginning I didn't give it a title. The moment I save it, it gives it title. So I do save as, and I call it test1. Oh, in the MATLAB files, never use mathematical operators. So never use dash because it is going to be interpreted as minus. Never use plus. Never use star, and never use slash. So let's call it test_1. And automatically he saves it as an M file. I save it, save. As you can see here in the editor, the name now is test1.m, and then I run it with run. I run it, and in the command line, I see that I run the file test1, and I see n equal to 100. This means that my command is verbose. That my command is, the result is shown on the command window. And sometimes I don't want my commands to be verbose, so I put a semicolon. If I put a semicolon, I run my program again. You see, n equal to 100 is not written because there is a semicolon. So generally, I put the semicolon after every command, unless that's an important result for me. Okay, so I want to draw 100 points, and so I want to make an index that does 0, 1, 2, 3, 4, 5, 6, 7, up to 99. So from 0 to 99, I have 100 samples. So I create a vector n equal to all the numbers from 0 with steps of 1 until n minus 1, semicolon. And if I run this, show you. And let's take away the semicolon. I run it. And of course, n will have all the numbers from 0 to 99, as you can see. When the step is 1, I don't need to specify. So I could just write 0 to n minus 1. Because the step is 1, step equal to 1 is the default. But I'm going to put step equal to 1 just for completeness and semicolon. Then I make a vector x equal, and just a second, do you hear noise in my background?
Some, but it's not.
No,
Right.
because I should close the
Yes,
door.
we hear Fred.
I know. The problem, if I close the door, I cannot hear Wi-Fi very well. So it's, my Wi-Fi goes down, so it's a little bit of a trade-off. Yeah, you have to be patient. I think it's calling Ricardo. Okay, let's write a sinusoid, for instance, with the frequency f0 equal 0.1, semicolon. And then cosine of 2 pi, so 2 times. Pi is a defined constant. I can write 2 times pi times f0 times n. Okay, let's see. 2 is a constant, pi is a constant, f0 is a constant, but n is a vector, okay? A vector 0, 1, 2, 3, 4. When I do a function of a vector, because this is a cosine of n, basically, x becomes a vector itself. And let's show it by doing this. I'm going to calculate size of x. So I generate a vector that contains the value of cosine of 2 pi f0n, and then I look at its size. I should get a vector that contains 100 points. And as you can see, my answer is 1, 0. It has, so vector x has 1 line and 100 columns. So is a row vector of 100 points. Now I can plot it. And to plot it, I can open a figure. This will open, and actually, let me show you. Let me run the program. When I type run, automatically MATLAB saves whatever I have written and runs it, and overwrites the previous file. So remember, if you make modification in a file, and then you just run it, the new modifications are going to overwrite what you had before. So if you want to make modification, but you don't want to lose what you had written before, you have to change name. So you have to save your file with a new name before you run it. Because run it just doesn't mean just run it. Run it means save and run. So overwrites and run. So I run. And as you can see, I open the figure and I have a figure here, but there is nothing inside because I have to plot something. To plot something, I use the command plot. And I can just plot x, for instance. Semicolon. Let's see what happens. Run. Yeah, this is my sinusoid. And as you can see, maybe you cannot see very well, but the first sample is in 1. Because when I just give plot, the vertical axis is whatever function I'm plotting, which is typically represented inside the vector. The horizontal axis is the index of the vector. So the index of vector x are 1, 2, 3, 4, 5, up to 100. Vice versa, the grammar of the plot command, I write it here, would be this: plot x, x variable, y variable, okay? This should be the grammar. So when I just do plot x, I'm just giving the y variable. So he uses as x variable the index. It's like I'm doing this. If I want an actual X variable, I have to add it. So in my case, the X variable is the variable N. So this is a more correct way of writing my command. And if I give this command, in fact, my first position is in 0. Please be patient. In my house, the phone rings and people talk, but I cannot I cannot silence my microphone. Actually, let me silence my microphone 1 second, because this is.
Marina, you know, it's not that loud. We can hear you pretty well. At least I can.
Sorry, guys, that was Riccardo. So, yeah, writing with the X and Y axis is generally the best option. By the way, let me just put the chat. Wait a second. Let me put the chat so that if you have. Okay, Alfredo. For some reason, I have an arrow next to plot X. I don't know what you did. Alfredo, do you want to share your screen and show me why you have an arrow next to plot X?
Well, I'm using Zoom through my phone, and I'm on my laptop. I'm using MATLAB on my laptop, so I can't.
Okay. So the arrow is here.
It's right in between the 9 and where it says plot. It's pointing towards the plot.
I don't know. Unless, did you do something like this? No.
No.
I don't know why you have an arrow, because yeah, if you click here, this is a stop point. Like you can run just a subset of your program. I don't know. You may have why you have an arrow.
It's like slightly to the right of that line,
yeah,
or that circle that you put. It's like right next to that. But I'll try to get.
Yeah, I don't know. But if you run your program, it runs.
Yeah.
Okay, I don't know what it is.
Well, actually, I think it's because I paused it or something.
Oh, you may have paused it.
Yeah, I think that's what I did. Okay.
Okay, the plot command, this has nothing to do with image at the moment, but it's just to get the basic of MATLAB. Plot command, you can give it options. For instance, when you plot something, you can do it in a particular color. For instance, this way I plot in red. Okay, so if I run, it comes out in red. And or if I do --r, I'm plotting in dash line in red. Or I can plot using O is sorry. O means I'm plotting little circles in red. Yeah. And of course, I can put little dots to see where are the samples, and that a continuous line. Yeah. So this is to show where are my samples, because this is actually a digital sequence, so I don't have the continuous signal. I just have some samples. And okay, if I don't put any option, E plus in blue with continuous line. And then, like, for instance, I can put a title. So title, and a sinusoid. When I put a title here, I have to put characters. And to write something in character, I can put it in quote unquote. So it becomes a title sinusoid. And also let's put a legend. Legend, let me see, I put a legend equal cosine. Yeah, there is the legend and there is the title. And this is more useful when you have multiple plots on top of each other. And we often like to plot multiple plots on top of each other to compare things. So for instance, let's plot a cosine and a sine. So I do, let's see, x1 is my cosine. And let me copy and paste. And x2 is a sine. It is a sine. And then I'm going to plot them on top of each other. So how can you do it? I plot x1. It's going to come out in blue. Then I do, hold on. I can also do it on the same line. I hold on. Hold on keeps the figure. So if you plot something else, it will go on top. And then I put plot and x2. And x2, I'm going to plot it in red. Then let me put a grid on. And then in the legend, now I have two plots, so I have to put two legends, cosine, comma, and sine. And here I call it sinusoids. And let me run it. Oh, here it is. So I have cosine, and I have the sine, is each one with its own label. So the labels are put in order. If you put 10 plots on top of each other, you need to put 10 labels. If you put just 8 labels, okay, if you put more labels, it's going to discard the last one. If you put less, it's probably going to give you error, I think. And you can notice, you know, it has a linear interpolation, so it just draws a straight line between the different samples. So for instance, this sinusoid looks like chopped because, you know, you're missing the samples in the middle, and the plot command just does linear interpolation between one sample and the next. Okay, so input-output, in particular of figures, is very convenient. You can change the colors very easily. And by the way, when you have your figures, if, for instance, you want to generate an external output, you can do here in File. No, okay, no, it's not File. In Edit, and you can do a collection of things. Crop figure, you can change the figure properties, the axis, the color, and so on and so forth. Insert, labels, titles, change the colors. There are various tools. One of the most useful thing is File, Save As. You can save your figure with a name, for instance, figure 1, but then different formats. You can if you save it as a .fig, this is a MATLAB format. If you open it again, you're going to see it exactly like you see it in MATLAB. But there are other formats. If you click here, in particular, all the graphic formats. So BMP, EPS, JPEG, PDF, TIFF, and so on and so forth. For instance, if you save it as JPEG, click save. Then I go back to here where I was, VC Tools, and I have a figure, Fig1, and I open it. Yeah, and this is my figure. And so, for instance, you can import your figure in any report you are writing, or in doc, wherever you want. Let's go back to MATLAB. And okay, other things that can be useful in MATLAB is the definition of matrices. Also, because our images are going to be matrices. To define a matrix, let's define, for instance, a matrix A, for capital A. You can define it simply by putting a collection of values. So, for instance, if I do 2 and 3, like this, this is just a vector. This is a raw vector that contains 2 and 3. And let's do this. Let's comment everything we did. Oops, sorry. Let's comment everything we did before, because we are not going to plot figures anymore. Or to comment everything, you can just mark it. You right click and you do comment and puts all the percentage values. So A equal 2, 3, if I run it. Yeah, this is a raw vector you see with 2 and 3. Or if I put a semicolon, means that I go to a new line. So this is a column vector. First row, 2, second row, 3. And when I run it, I see it like this. Let's make a more complicated matrix, for instance, a square matrix. So 2, 3, new line, 1, 4. 1. I need to put my zoom somewhere where it doesn't. Okay, this is A. And you see here it's marking it like red because it tells you that you should terminate your statement with a semicolon if you want to suppress the output, but we know that. And MATLAB has built in a collection of functions that can do a collection of matrix operations. For instance, if I do A prime like this, this is going to be the transpose. Then if I do inv of A, this is the inverse. The determinant, I don't remember. I don't remember the determinant, maybe that. When you don't remember a command, if you have a vague idea, you can just do help that. Let me see if that exists in the command line. Help that, it tells me that is the determinant of the square matrix X. Yes, so that is the determinant. So that of A is the okay, so let's run it. Run. Okay, so let's see. The last one, 5, is the determinant. So let's go up. 8 minus 6 minus 0.2 minus 0.4. This is the inverse. and 2134 is the transpose, and 2314 is our matrix. So we already have a large, let's say, library of function that can be used. And for looking for functions, you can, I repeat, either use the help command on the command line for a quick help, generally to know how to call a function. For instance, I remember that to perform filtering, there is a subroutine that's called filter. So I can do help filter, and it gives me some explanation, but more than, I'm going back. More than anything, it tells me, how do I call it? I call the subroutine filter this way, output equal filter, and then there are some parameters that define my filtering. So I know here that I need 3 inputs. Otherwise, I find the help here under question mark. This is a kind of web-based help with many more commands. Another thing that can be done, you just open the web, Google or the web, and you say, how to filter in MATLAB. That's it. There are tons of answers, rooms where you can discuss. You always find an answer. Filter data, yes, moving in. And here you find generally some suggestion on how you can use your commands. Questions? Let me see. No, nothing in the chat. Everything okay up to now?
I was wondering how you put the green text next to the command
How you put the green text with it?
on the MATLAB.
This? Actually,
Yeah,
what
yeah,
happens, okay, this is automatic on my MATLAB. Like when I put the percent,
Oh.
it writes in black, okay? But when I put the percent and it knows it's a comment, then automatically marks it green.
Okay.
Your MATLAB doesn't
No,
do it?
it does. I just didn't know that it did that.
Yeah, it does it automatically.
Okay, thank you.
And okay, other ways to define matrices.
Hey, Marina, this is
Yes.
a question about something that you didn't really bring it up, but I'm just curious. Like in Python, you know how you're able to like have a print statement that combine, like how do you print something? I guess that's my question.
Oh, you print, yes. Print, I don't
Like for the matrix.
yeah. You want to print a like a command. No, a command.
Like a
sentence on the screen.
Then, yeah, so you're combining like string characters and then like your, you know what I mean? Like I want, like if you wanted to say, oh, this is the transpose of the matrix, and then you say M apostrophe after that, or like A apostrophe after that. Like, how do you print that kind of a statement too?
Yeah. Okay. Let me see. Let's imagine. Okay, let's go back. Let's imagine here you want to write legend sinusoids at frequency f0 equal, and then you want to put the number f0, okay? So you have to do this. First of all, you have to transform f0 into collection of characters, and the command is, we call it f0 string, F0 string is num to string F0. I think is num to string. Let me check. Help num to string. Num to string converts numbers to character representation. Yeah, num to string converts number to character representation. So now in F0 string, I have the number F0, but into a character. Then when I print, I have to combine the characters sinusoid at frequency F0 with the character F0 string. And I do it like this. I make like a vector of characters. So I open the brackets. I have the first element in my vector, then a second element in my vector, F0 str, and I close the brackets. So this is a line vector of characters. Let me comment this. And let's run it. So here, sinusoid at frequency F0 equals 0.1. And let me, sorry, I always have this zoom. I don't know where to. Oh, let me do this. Wait a second. Let me. Okay. Do you still see my MATLAB?
Yeah.
Ah, okay. Is this what you were asking, or you wanted to write like a comment, like, I don't know,
Like
everything is in error?
Well, if you had like a print,
yeah.
Like
so
a
I don't
print
remember. I don't remember exactly how you do the printf. Wait.
Oh yeah, I just wondering.
Wait, let me check. Here, it may be this, because when you give a command, when you ask help for a command, it generally also writes anything that's related. Okay, so sometimes I use it to try to understand what I'm looking for. So as printf, let me see, as printf. Oh yeah. As printf, write formatted data to string of character or vector. So yes, printf. Yeah. So for instance, let's see. If I do, let's take one of the examples. Oh yeah. If I do printf as hello, yeah. Yeah, so here there are a collection of examples. Sprintf allows you to do printing of something with a certain format. So for instance, let's copy hello. Here. Sprintf as hello, let's run it. Yeah, it types hello. Okay. For printing of characters. I just commented to remember what I'm doing. Okay, and also let me show you other ways of generating simple matrices. Another way of generating matrices is the command ones. Ones generate matrices full of ones. So for instance, if I do 1, 2, 3, it makes a matrix full of ones with 2 rows and 3 columns. run 2 row and 3 columns. About this. And then another command is, of course, zeros. I think it's zeros without E. I don't remember. So for instance, if I give 4, 1, is 4 lines, 1 column of zeros. Then, so 4 rows, 1 column. And then what else? I think there is, if we do, for instance, the command I generates a diagonal matrix full of, with ones on the diagonal of the dimension equal to the parameter. So for instance, if you do I of 3, it should make a 3 by 3 matrix with 3 ones on the diagonal. Let me see if this is right, and let me comment the initial figure because I keep reprinting this. Yeah, the command I generates an identity matrix with all the ones on the diagonal. Okay, then let me show you some other command. Imagine I have my matrix B. Let me make my matrix B a little bigger. Let me see, 3 rows and 5 columns. Yeah, so B, when I type here B, it gives me the current value of B. Yeah, this is B. And I, wait a second. Instead of that, let me make a matrix. I call it E. Always dimension 3 times 5, but instead of ones, I put rand. Rand puts random numbers. Oh yeah, this is my random matrix. And let's imagine I want to eliminate the 3rd column. How can I eliminate the 3rd column? I can do this. I generate a new matrix F. I want to generate a matrix F that contains the 1st, the 2nd, then the 4th and the 5th column of E, and I want to eliminate column number 3. So I can do this. F is equal to E and I want all the rows. When I want all the rows, I put semicolon, comma. And as columns, I only want 1, 2, 4, 5. Let's see if I can run. Here it is. Okay. So this matrix is the same as the previous one, but I eliminated one column. Or let's do another example. I want G. I want to keep all the columns apart from the last one. If I want all the columns apart from the, let me show you this. If I do G equal E of all the columns of all the rows, this way with a semicolon. G is going to be equal to E. Another way of writing this is saying that I want all the rows and then all the columns from the first one to the last one. It is exactly the same thing. Let me run it. Wait then. Let me comment F. This is my matrix E, this is my matrix G. Then let's imagine I want to eliminate the last column. I can say that I want all the rows from the first to the last one, and is an automatic variable. When you write and, he finds the last index in that vector. And here I want all the columns from the first to the one before last. So this will eliminate the last column. Let me run it. As you can see, they are the same, but the last column is being eliminated. And if instead of n minus 1, I put n minus 2, I'm going to eliminate 2 columns. And this eliminates 2 columns. Another thing that I can do is to keep all the rows, and I want only the odd columns. So 1, 3, 5. So I can do this. I want the columns from 1 with steps of 2 until end. Let's run it. And as you can see, I kept the first column, the third, and the fifth. Listen, my time is finished, but at least this was the beginning for everybody who didn't know MATLAB. Those who already knew probably didn't need this, but it's better to start all together. Give me a feedback, ask questions. I was thinking of stopping here for today.
Yeah, this has been very helpful.
Yeah, it seems pretty good. Thanks so much, Marina.
It's good. So listen, next time we are going to start with actual images. So we are going to take images, we're going to transform it into matrices, and then we can process them using this kind of commands. And that's it. Let me stop recording. Oh, how do I stop recording? So do you want me to upload the video?
Yeah, it's recorded already, right? Yeah.
Yeah. Wait,
Why not?
wait,
You have to, Marina, you have